Okay. So as far as linked list is concerned, it is we can say whenever we define linked list, we should say that it is a linear data structure which is similar to arrays. So whenever we okay, am I audible to everyone? Yes.
Yes, sir.
So whenever we speak about linked list, it simply implies that linked list is a linear data structure. So whenever you have been asked in orals what is a linked list, so we should remember that it is a linear data structure. That means it can be accessed in a linear fashion. Since arrays can be randomly accessed, but linked list cannot be randomly accessed. They have to go through the sequence of start to end two pointers. So first pointer is always pointing to the head node, whereas the last pointer is sometimes optional because the last pointer is always indicated the last pointer is always indicated by a null value. Now as far as this diagram is concerned, you can see that we have defined the structure for linked list. So it is very important that we should define the structure for linked list, and as far as C programming is concerned, there is a keyword struct struct is used to define the structure. It is quite similar to classes, but the difference is that there is no direct association of the structure variable with the functions. So only difference is that there is they are similar to classes. Now the another to understand is the concept of pointers. So what is the concept of pointers? First of all, the screen is not visible now because there is light has been just gone on the desktop. Continue the session. Don't worry about the presentation. We will also continue them as soon as the system light power is on. Now, the most important thing over here is to understand the concept of pointer. What is this pointer? Pointers are nothing but address of memory location. You can take down this important concept that pointer is nothing but address of memory location, and as far as C programming is in concern, they can directly access your RAM, RAM, capital RAM. So anybody knows about the concept of RAM? Yes, participants. What is RAM? Okay. So whenever your program is executed, it is first written on your hard disk. So the program you are executing, for example, abc.python or py, this is the program. So what it does, we save that program on your secondary device, that is hard disk, and when the program is going to compile and execute the results into the RAM. So can we say that the program has two behaviors? One behavior is inactive behavior, where the program is just written and saved as a file. Another behavior is the runtime behavior. Now, whenever we are writing a program, we say it is not a writing a program, it is designing a program. our engineering concepts or technical concept, we have a design view, that is RAM, and second is the runtime environment. So we have design environment and runtime environment. As far as developers are concerned, they are concerned with the design environment. So as a programmer, your task is to design the program. Okay, everyone able to understand what is the main task of the programmer? Yes, participants. So whenever you write a program, it simply implies you are designing the program, and that design is being in the terms of your .c file or .python file or .cpp file, even your Java file. So whatever you write a program, it is simply a designing of a program. So how to design it? We know that it is based on algorithms and flowcharts. Second concept is that we are working in the runtime environment. So when the user runs a particular program, that is the runtime behavior of the program, and it simply implies that at the runtime there is only the user is only the client and not the developer. So we have to think as a user what difficulty or what parameters he may require at runtime. Okay, so the runtime behavior is runtime behavior is little difference. For example, you are designing a software for students marks entry system. We'll take the simplest example and consider the variations over there. What will be the variations? We'll find that every class will not have same number of students. The number of students may be changing. In some classes there may be 50, in some classes there may be 100, in some classes there may be only 25, and so on. Design the worst case behavior. For example, you will take the maximum number of students in the class and program as a designer. So what will happen? There is wastage of memory. So we can say it is memory hungry. The program will take lots of memory, and due to this we say that it is not an optimal program. In runtime, there may be some requirements, additional requirements. For example, you design a system for 25 students, and at runtime, there will be some more students, say 50 students or 100 students. So if what will happen if the number of students increase, then you have to modify again the data structure, and therefore we say arrays are not that much flexible with respect to a series of data. We have to use dynamic memory allocation. So that is the significance of dynamic memory allocation, where the utilization of memory is achieved. Now, as far as dynamic memory allocation is concerned, there are two keywords which we try to mention. First keyword is malloc, M-A-L-L-O-C, malloc in C programming. Keyword, you will have the syntax of malloc. So, in malloc, you have to specify the size of data type. For example, the data type is integer, then it will allocate 2 or 4 bytes based on your compiler. Then another keyword we are going to study in dynamic memory allocation is nothing but new, NEW. So suppose you are using classes, then this keyword is being utilized. So we have okay, some message is there. Yes, what was the message? It is not visible. One second. Cut off at the office, but we are continuing as the power will might come in 10 minutes or so. Therefore, the screen is not visible. So, shall I continue with this, or will continue after the light comes? Yes, participant. Yes, shall I continue, or will continue after the
Yes,
light? Or yes, Gayatri. Okay.
yes, sir,
So
you can continue.
it is very well. I hope everyone understands this. Okay. Lecture चालू आहे मला सांगा ना. Okay, so as far as dynamic programming is concerned, we have only introduced to the linked list, but there are various other data structures which will support this dynamic memory allocation. So we have two categories in data structure. One is linear data structure and other is non-linear data structure. So in advanced data structures, we will cope up with non-linear data structures, both have their advantages and disadvantages. But as far as Unit 4 is concerned, we will stick to linear data structure, that is linked list. Now, consider that we have to store a data for one single student. Now, the word is store. So where to store it? Yes, anybody can tell me where we store the data? Yes, participants, where we store the data in computers? Anybody? Yes, anybody can guess? Okay. So I have always told yes. So whenever your program is in run state, you store the data in RAM. And whenever your program is in what we can say it is not running, you should store it in hard disk. That means the software will have two storage. One is the permanent storage and another is the temporary storage. So if it is temporary storage, you will use RAM, and if it is a permanent storage, you should use hard disk. Now another concept which is to be understand is VRAM, that is virtual RAM is there. This can also be used for temporary purpose. How it is there? Have you heard about temporary files in your operating system? Have you cleaned temporary files in your operating system? Yes, participants?
Yes, sir.
So that is a temporary storage of hard disk. So your program can also use two types of storage. One is the permanent storage, another is the temporary storage. In temporary storage, you can use VRAM, that is the virtual hard disk, and another you can use your primary memory. Apart from this, we have the cache memories, so which is speeding up your execution. So when your program is going to execute, it will first come into the RAM, and then it is loaded into cache memory, and above cache memory we have very high speed memory, that is registers. So registers are even faster than that. So in a microprocessor, have you have microprocessor subject? Yes, participants? Do you have microprocessor subject this semester?
No, sir.
Okay. So what happens? There is various types of memory we should know. So the fastest memory is the register, which is nearer to the processor or inbuilt in the processor. Another fastest memory is cache, which is built on as a chip in the processor itself, microprocessor itself. And the next level is your RAM, and another slower memory is your hard disk. And apart from hard disk, we have that pen drive, storage device, and so on and so forth. So what happens? Your program is going to access all these types of memory. They are going to access the registers, they are going to access the caches, they are going to access the RAM, and they are going to access the hard disk. So when we say about pointers, we should remember that pointer is directly concerned with your RAM. Okay, yes. Now, when we say that what we can say register is the fastest memory, we can directly write C programs where you can utilize that registers and you can write high performance softwares. So as far as robotics is been concerned, so if you see that the robots are performing very faster, then you have to do hardware level programming. And one of the language, that is embedded C, that supports this kind of programs. So it is C program and the type is embedded one. So with pointers, we should be careful that you can access any memory location in the RAM. That is the risk of using or dynamic memory. What I have to say that whenever we use the pointers, you are accessing the RAM any location. So you can write to any location. And what happens? If you write or update a particular operating system contents, then what will happen? Your system will crash. And it is a type of virus which can execute in any memory location or in the space which is allocated for operating system. So for this you have to avoid pointers. Okay, but if your requirement is directly integrating with pointers, it has very dynamic applications. We have to be careful that your compiler will not go into the memory location where OS files are being stored, and it will not update that. So that is the thing, because I already told you that it can access the virtual RAM which is on secondary memory. So if you use pointers, it can update any memory location. So we have to avoid this and work in the user area of out of the OS. So this concept of pointer is very interesting. Now what happens in dynamic memory allocation? When we use a malloc keyword or the new keyword, it will allocate a block of memory. Okay, so we have discussed about memory space requirement or space complexity in the lecture which is concerned with dynamic memory allocation. So as we calculate the space and we allocate the memory, until and unless we use the free keyword or delete keyword. So if we free the memory or we delete the allocated memory, the RAM is been constantly allocated to the program, even though until the program is running, that memory is not utilized. So to make memory efficient program, we must use malloc and or new keyword and free the memory or delete the allocated memory at the end of the program. So two concepts are there. One is allocate the memory and second is deallocate the memory, that is remove the memory, as far as dynamic memory allocation is concerned. We have discussed that a student information can be called as a node. The first is naturally the name of the student, roll number, class, and each subject marks. Suppose he is attempting 5 subjects or 10 subjects. Now again here is the variation. may happen that the student may not having same subjects, they are giving very different subjects, or the number of subjects may differ for each students based on the classes. So here again you require dynamic memory allocation. So we should, as a designer, we should identify where dynamic memory should be allocated, where static memory should be allocated. Okay, so for example, I want to use a data structure for name. So data structure is simply string. So what size will be there? Yes, anyone can we guess about what will be the size of name of a particular student? How many characters it will be there maximum? So we can guess that there can be 50 characters maximum. It is more than sufficient, or we can say 20 characters is also sufficient. So these are some of the problems that must be listed and that must be answered as a designer. So you think that whenever you are talking about data structures, you are designing the software. Everybody should make this, that it is not about writing the software. Anybody can write. The code is available on the internet. Yes, yes, participants, do you agree with the statement? Sometimes the code is available on the internet and anybody can write the code. Yes?
Yes, sir.
Okay. So, yes, so programming is not a big task. What is the big task? It is designing the software. Okay, so in most of the students, what they think that coding is the easier task. Just copy the code from the internet, execute it, it is available for us. But in fact, engineering is nothing but designing the software or designing the code and not writing the code. So a coding concept is simply, just a minute, just light the light has come. I'll just start the system in 2 minutes. Just give me 2 minutes. Okay, as the system starts, we'll continue. So when we talk about designing the software, it is really risky because what we are thinking in designing, we are thinking about what are the requirements of the software, what will be the data type. Second is how to mold that data type into a node and entity, and how to link that so that it will work efficiently, which are the functions that should be get the expected results. So this data we have the class. So you have to remove one student. Okay. So the operation that is required is delete a node. If dynamic memory allocation is concerned, we have at least two operations. One is add the student to the linked list, and another is remove the student from the linked list. So minimum two operations, that is add and remove the student. Okay. Third is, that is most important operation, we have to search a particular student. So it is all about searching a student in the linked list. So third operation is add, delete and search. Another important operation that is concerned with linked list is we have to sort the contents. So sort the student according to highest marks for the purpose of admission or for the purpose of top 5 declaration and so. So these are operations that are associated with the data structure. So as a programmer or the designer, we should know which operations to be developed with respect to a data structure. So when we write a note about the data, variables or members of a data structure must be there, and the operations required to execute the data structure both, then it is termed as ADT. ADT. Take it down. ADT means abstract data structures or abstract data type. It is ADT. So abstract data type gives you the entire information of the data structure, as well as it will give you the overview of your design. So as a programmer, as a designer, we must first able to understand ADTs, and if you are able to understand ADT, then and then only you will able to define the data structure, as well as you can go into program the data structure. So still there is internet issue, but I hope everyone is able to understand the concept about and the significance of designing of the software. As in first year, that is PPL, we have studied or learned about SDLC models. Do you remember SDLC models? So SDLC is nothing but software development life cycle, and we have to follow the SDLC models. So whenever you design a software, you have to follow the SDLC model. That means first you have to gather some requirements, then you have to analyze them. Fourth point over here is after designing there is coding. So in this DSA subject, it is little complicated to understand the design. As the student view is concerned, they are thinking about coding. So coding is not designing, that is different. Coding is different and designing is different. Yes, participants, and the significance of the subject DSA. Yes, everyone. One second. Okay, the slide has come. So I'll just share the screen again. Yes, participants able to view the screen.
Yes, sir.
So what we are seeing over here, it is a design. Okay, and based on design, we have to understand the various operations. So you can see that I highlighted a node. दिख रहा है यहाँ पर? Yes, everyone. Okay, so node is a single data element which has two things. One is the data, that is data members, and another is the address. As far as linked list is been concerned, we are having the next pointer, so it will store the address of the next node. That is the thing of my design. So I have designed a basic node which contain a data element and it will have the next pointer. Everyone able to understand the design view or any query? Yes, participants? Okay. Now look at over here, memory requirement. So what is the memory requirement of one node? For data and for address, I am using 2 bytes. Requirement by a node is 4 bytes. Understand my design? Yes, participants? Yes, everyone? Understand the concept of node and memory requirement? Yes, any query? Okay. Now I am going to organize this into 5 nodes. So I have created 5 nodes. Node 1, node 2, node 3, node 4 and node 5. In RAM, so I know that I have created the node at runtime. So we have used either a keyword malloc or new. So you should remember, creating a node using dynamic memory allocation will use the keyword or malloc or new keyword. Okay, has entered the data value as 50 and my node is having the next address as 100. That means the node 2 address is 104, node 1 address is 100, node 3 address is 204, and so on. So the address part is hidden at runtime, which is not being seen by the programmer, but it can be accessed. How it can be accessed? We can store the reference in the next pointer. So over here, the next node of node 1 is node 2 and node 2 address is, and therefore this 104 is stored in the next pointer. So when we say any node next to node 1, you get the answer as 104. So 104 is the address of node 2. Similarly, if we connect node 3, so node 3 address is 204 and it is connected to node 2. So the next pointer of node 2 will have the address 204. Able to understand how I am linking it? Okay. Now linking of node 3 and node 4. Node 4 address is 504 and node 3's next address is 508. So 508 and 508 will have the node 3 arrow next will be connected to node 4. Then next is node 5. Node 5 address is 1000 and there is to be linked node 4 and node 3. have the next pointer of node 4 as 1000. So can you say, is it programming or design? Yes, participants. Can we classify this? Is it programming or design?
Designing, sir.
Yes, very important concept. So coding is the supportive method which will convert our design into a program. As far as a good software engineer is concerned, you should able to understand the design the code, and understand the linking of the nodes. So now, accessing these nodes, we have designed it and how to access it. So I label something. What we label? Node 1 should be labeled as head node. So this is my design again. I label node 1 as head node, and naturally my last node is expected to be end node. Everyone getting this, that I have labeled node 1 as head node and anything that is last node is end node. Yes, participants, did you understand the design?
Yes, sir.
Okay, so whenever there is first node is created, so then what will happen? The head node and the end node will be same. Now suppose we want to add another node to the first node. So what we'll do? Add at the end. So we have appending the node at the end of the linked list. So we say end arrow next is the address of the new node. Okay, so that is the logic of design. So we say over here append operation. So append operation, how to perform it? We know that the first node is node 1. Now we have created the sixth node, new node, to be appended into the linked list. So we have some information and we have to add it at the end. So which is my end pointer? So my end pointer is at node 5. So we say end arrow next must be updated. Over here it is null in this field. So null means end of the linked list. So this null is to be updated. So if you update this null value with the address of the new node, the next address of node 5 with 1200, which is the address of node 6. Node 6 is linked with node 5. And since node 6 is the end node, we will set the next address of node 6 to null. So again, your end pointer is now shifted to the last node, that is node 6. So this is the operation which we design to append the node. Everyone understood the design? Yes, participants?
Yes, sir.
So as we create node 1, node 2, node 3, node 5, we have also added node 6. Similarly, if there are 60 students, we can add 60 nodes and we can link them in a linear way. Therefore, the data structure is termed as linear data structure. Yes, everyone understood? Okay, so we'll go through another operation, that is we have to delete some part of the node. Suppose we want to add node 7. So what we'll do, simply update this null value with 1250 is the address of node 7 and link it at the end. So this was as far as appending is concerned. Now another operation is inserting a node at the beginning. So suppose you want to insert this node 7 at the head node. So what we should do? So over here simply we have labeled it as temp and we have to make it as head node. So what you do in this next pointer, so you can see the data structure which I have designed for node 7, the next pointer was null. Able to you? Yes, participants? So node 7 data next pointer is null, which is now updated. So update its value with the first node. So first node address is 100. So what you do, you just update it next pointer to 100. Okay, and just make temp is equal to head. So you set a simple function, that is temp is equal to head. So let's say head is equal to temp, and your head pointer will point to node 7 as the starting of the linked list. Clear? Yes, participants? So over here what we have done, we have inserted that node to the beginning of the linked list. We have studied two things. One is appending the node at the end of the linked list, and we studied another thing is appending the node at the beginning of the linked list. Now another interesting concept. What if you want to insert a node between node 3 and node 4? So I recommend all of you to design your logic how you can insert node 7 or node 8 in between node 3 and node 4. Yes, participants, this is your task. Okay, so how to insert them, what will be the logic of insertion between node 3 and node 4. Getting the requirement of the design. Yes, participants. Okay, so we'll study another operation. So we are going to study the ADTs now. So that is deletion operation. So what if you want to delete the head node? So simply we say temp is equal to head is equal to head arrow next. So head will move from this position. It was head is equal to node 7. So when we say head is equal to head arrow next, it will move to node 1. And simply use the keyword delete temp. So I have already discussed this. When we allocate the memory, we have to free it. So we free the memory using delete keyword if it is allocated by new. Yes, participants, able to understand the deletion operation? So similarly, as insertion has three phases, that is insert at the beginning, insert at the end of the list, and insert in between, we have three options in delete also. That is delete from the head node, delete at the end node, and delete any intermediate node. So again there is a design operations, that is we have to delete the first node. Then how to do that? Design it. Delete the end node. Then question is how to delete it, what will be the changes in the design, and what will be the operations to be performed. Okay, now last question, how to delete an intermediate node. So this answers is been processed by the designer. Then next operation after design is traversing. That means how you access the linked list data from the head node to the end node. Okay, so we are currently working with linear data structure, so we are going to access it sequentially. Naturally, there is an overhead of addresses, and so it is little slower than arrays is been concerned. So arrays are more faster and randomly accessed, but linked list has to be sequential access, and therefore we will have various versions of linked list. We will see the designs of various data structures. Currently, you can take the names of them. We have circular linked list. Okay, first is single linked list or singular linked list. Then we have circular linked list. We will see these designs in upcoming session. Then we have doubly linked list, that is two-way linked list. Next is we have doubly circular linked list, DCLL, that is doubly circular linked list. So the concept is little more interesting as we move into the designing process. Another operation is how to perform concatenation of two linked list, and we'll compare the performance of linked list with arrays. So another operation after concatenation of linked list, we have the program related to sorting of linked list. How to do it? We have to design the sorting concept, and finally some operations on polynomial using linked list. So as far as this session is been concerned, you can give the attendance. I'll just put up the code. I think the previous session code was 24 or 26, so you can put 27. Okay, so I'll just put the code for it. I think just a minute. I'll put the code for attendance. Okay, so it is CO oblique 01 oblique 27 input. Yes, participants, any questions on the designing process? So I recommend all of you to give the attendance. And we'll terminate the session over here. Thank you.